Hello everyone, this is me, Kunal Murki. Today I'm here to share a PowerPoint presentation on data processing and instructions. And I hope that by the end of this session, you would be having a brief knowledge regarding this topic. Coming on to the introduction part, data processing instructions play a vital role in modern computing systems. They are a set of instructions or commands that operate on data, enabling computers to perform various tasks efficiently and accurately. In this presentation, we will explore the different types of data, instructions, execution cycles, and the examples of data processing instructions. So, what are the data processing instructions? Data processing instructions are a set of instructions or commands that manipulate the data within a computer system. These instructions enables the computer to perform arithmetic operations, logical operations, and the control flow of the operations on the computer data, making them fundamental for data manipulation and computation. So there are different type of data processing instructions. They are arithmetic instructions, logical instructions, and control instructions. Arithmetic instructions are used to perform mathematical operations on data such as addition, subtraction, multiplication, and division. Logical instructions are those instructions which operate on binary data, perform logical operations including AND, NOR, OR, and XOR gate, and bit shifting also. And coming to the control instructions, these are the instructions that determine the flow of execution, including branching instructions and looping instructions, and even jumping instructions also. Now, moving further, data processing instruction formats. These are a specific format that consists of opcodes, operands, and addressing modes. The opcode indicates type of operation to be performed, such as arithmetic operation or a logical operation. Operands are the data or the memory locations on which operation is to be performed. Addressing modes determine how the operands are accessed, whether it can be immediate addressing, direct addressing, or indirect addressing. Now coming on to the execution cycle of data processing instructions. There are four types of execution cycles. They are fetch, decode, execute, and store. The processor fetches the instructions from the memory in the stage 1, and in the next stage, the fetched instruction is decoded to determine the operation to be performed and the operands are involved. And in the third stage, which is execute, the processor executes the instructions by performing the specified operation on the operands. And in the last, the result is stored back to the memories or a register. There are common data processing instructions in central processing units. They are addition and subtraction, logical operations, shift operations, and branching instructions. Addition and subtraction instructions are fundamental operations for numerical computations. Logical operations are logical and or and not operations that are essentially used for manipulating binary data and making decisions. Shift instructions allow shift bits left or right or to multiply or to divide by powers of 2. And coming to the branching instructions, these facilitate conditional execution of the program to make the decision based on specified conditions. Let us just take an example whether how these data instructions will work. So there are different type of instructions such as move instructions, shift instructions, and arithmetic instructions. Here in move instructions, MOV R0 R1. It means it moves the contents of R1 into the register 0, and move R0 hashtag 3. This means it moves the number 3 into the register 0. Now coming on to the shift instructions, the input of the operation can be shifted. Here MOV R0 R1 LSL hashtag 2. It means it moves R1 which is less than 2 into R0. Now MOV R0 R1 ASR hashtag 2 moves R1 which is greater than 2 into R0 where the sign is extended. Now lastly, arithmetic instructions. Here add R3, R4 and R5. Here the value of R4 and R5 which is to be added is stored in the register R3. This is how the data processing instructions will work. So now coming on to performance optimization techniques, we have different techniques to enhance the performance such as pipelining, parallel processing, and instruction level parallelism. Here, many instructions are executed parallelly at the same time to increase the efficiency and give a better output. Pipelining is a technique that overlaps the execution of multiple instructions, improving throughput and reducing the execution time. Parallel processing involves the simultaneous execution of multiple instructions or tasks, harnessing the power of multiple processes or cores. Instruction level parallelism focuses on execution of multiple instructions in parallel with a single processor, exploiting available resources efficiently. So now, coming on to the conclusion part, data processing instructions are crucial for manipulating and processing data in computer system. The importance is that they enable arithmetic, logical, and control operations, providing the foundation for efficient computation and program execution. The impact is that it advances the instruction execution techniques and optimization strategies, continuously enhancing the performance of data processing instructions. So, in closing, I would like to express my sincere appreciation to everyone for listening to the presentation regarding data processing and instructions. And I hope that this has helped you in some or the other way. And I would like to thank you for all the attentiveness.